Welcome to another video that explains why the length of the string 4 is 5. C doesn't have a built-in type for strings. Instead, it uses a sequence of characters ending with a special null character, which is appropriately called a null-terminated string. This is how C knows where the string ends. In our example, the string 4 actually takes 5 bytes in total, 4 letters, and a null terminator. If the null character is missing, the program can read or write past the end of your string, which is commonly known as buffer overflow and may cause crashes or be exploited as a security breach. Let's unpack all this. There are two ways to represent a string. The first is an array of characters. It is a local variable stored on the stack. You can modify its contents. If you initialize it with a string literal, like here, you don't need to provide a size. For example, you can write car4 equals 4. But you can also write this, which will simply reserve memory on the stack. The second, more popular way is a pointer to a car. This allows for strings of dynamic size, which is not possible with arrays. Here, for instance, we compute the size of the string. Note that strlen does not count the null character. Then we allocate memory on the heap using malloc, and finally copy the string. You can also initialize a pointer with a string literal. If you write something like car*5 equals 5, the string literal itself usually lives in the program's data segment, which is read-only. Trying to change it causes undefined behavior, probably a crash. Array and pointer semantics are broadly equivalent. Indeed, a reference to an object of array type decays into a pointer to its first element. For example, you can write *4 equals f to change the first character of the array. You can use subscript to access other elements, like 4 subscript 1 equals O. You can also use pointer arithmetic. The syntax is very common, and honestly the next one is just showing off. Thanks for watching and see you next time.